Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's topic, we are going to do the chapter 11.9 selection of tapered roller bearings. I've taken this content from the book Shili Mechanical Engineering Design, and the images I take from randomly from Google Images and also from the book itself. Okay, in this video, we are talking about tapered roller bearing, which is different from the previous video. The previous video, we're talking about ball bearing, and cylindrical bearing. Okay, cylindrical bearing is straight bearing. If now we're talking about tapered bearing, it's also cylindrical bearing, but it's at angle. When you position it, if you position in an angle, this angle is called taper. Okay. Tapered roller bearing have number of features that make them complicated. Okay, or as we address the differences between tapered roller and ball cylindrical and ball bearing, note that underlying fundamentals are the same, but the differences are in detail. Okay, so the fundamental is the same, how you calculate is the same, the details are in the differences in detail only. Okay, however, moreover, bearing income combinations are not necessarily priced on proportion to capacity, and then any catalog displays a mix of high production, low production, and successful special order bearing. Bearing suppliers have computer program that will take your problem description, give immediate design assessment, and list of number of satisfactory cup and cone combination. Okay, so we see what is cup and cone in the next slide. You see the nomenclature of the tapered bearing. Okay, so it is noted that company sales office can access to comprehensive engineering services, and at a large original equipment manufacturer plan, they may be resident bearing company representative. Okay, so if you're talking about you are lucky person, you are working in this big company, they may have a bearing representative company from the company inside your company. So you should not be not so worried about, because the person that in charge in the bearing is there in your company. Okay, so we see the next slide. The next slide is this slide talking about bearing suppliers catalog. Bearing suppliers provide a wealth of engineering information in detail in their catalogs and engineering guidelines. So catalog sometimes is so thick like that, so thick. Okay, both in print and online, it's strongly recommended that the designer become familiar with specific of the supplier. We will usually utilize similar approach presented here, but may include various modification factors such as things as temperature and lubrication. So the basic that we learn in this topic is quite the same. If you are go for detail, this company, they all have slightly variation. Like you're working in company like in 4 season, snow, hot, summer, and you're working in countries like Malaysia, only hot all the time. Okay, company in Middle East, hot all the time. So they have different spec, different configuration and everything, slightly different, but fundamentally it's the same. Okay, many of suppliers will provide only online software tools to aid in bearing selection. Engineers will always get benefit from general understanding of theory utilized in such software tool. Okay, the goal here, this book, okay, is to introduce the vocabulary, show congruence to fundamentals as that we learned earlier, offer example and develop confidence. Finally, problems should reinforce from learning experience. So again, you have your senior, you ask your senior, okay, you ask your senior from their opinion, because bearing has so much configuration. This book only provide basic fundamental for you. Okay. Okay, so this is a model bearing catalog. You can see this catalog. You can Google it. This is a model catalog. You can find example of the catalog. You can find this catalog. We have the C10 value. We have the C0 value, which is the force value, and also the dimension for the bearing and itself. Okay, the only thing that you have to learn in this book is to know how to calculate and how to select the most suitable bearing for you. Okay. So four components of tapered roller bearing. So you have the four. You can see the nomenclature here. Okay, they have the cone, they have the cup. Cone, which is the inner ring. Cup is the outer ring. Okay, where is the cone? The cone here, inner ring. The cup here, an outer ring. Tapered rollers and cage, space retainers. Okay, this is the cage. Okay, you can see where is the cage and where is the spirit tapered roller. Okay, so different in only nomenclature, because if you remember the ball bearing, we have the inner and outer. The same goes as for taper bearing, but in the taper bearing, it is called the cone, and it's called the cup. Cup, cone for inner ring, cone, cup for outer ring. Okay, and then also the differences in the angle, the position, everything. But as you remember, the only four main component: cone, cup, taper rollers, and cage. Okay, so as a bearing consists of two separate part: the cone assembly, the cone rollers, the cage, and the cup. Bearing can be as a single row, two row, four row, and transbearing assembly. Additionally, auxiliary components such as spacer and closure can be used. Okay, figure 11:13 shows the nomenclature of a tapered roller bearing and point G towards the radial and axial components of load act. Okay, so this is the nomenclature of tapered roller bearing. Point G is the location of effective load. Again, nomenclature that is the previous slide is the same like this, and it is the focus more. You can see where is the location for the cup, for the cone, for the cage, okay, for the cage, for the roller and everything. You can see this is the G, the center of gravity, the cone bore, and you should know. Okay, I suggest that you print, if you have the book, better this page, you print this page. So, when I talking about code, you refer this is the code. If you print this page, better for you. You can refer what am I saying. Okay, direct in and direct mounting. Okay, a tapered roller bearing can carry both radial and thrust load, a combination of both. However, even when external load is not present, the radial load will induce a thrust reaction within the bearing because of the taper. To avoid the separation of races and the rollers, the thrust must be races when equal or opposing force. One way of generating the force always is loose to two tapered bearing on the shaft. Okay, so on the shaft, the same goes as roller bearing, the same goes as ball bearing. It should have two. Okay, most, I'm not saying should have, but with most application they will have two. This is the shaft. You have this portion and this portion. You have two, two, two bearing. Okay, two bearing. Okay, so because it will cancel out the radial load, the thrust load of each other. Okay, if you only have one, it will consume all the loads given. Uh, Okay, this is the comparison of mounting stability between indirect and direct mounting, courtesy of Timken Company, which is the company that mentioned in this textbook. Two company mentioned in this book: SKF and Timken Company. Okay, so this is the indirect mounting. This is the direct mounting. So you can see here, indirect mounting. You can see the differences. If this picture is not clear for you, you can Google. You can Google the images. As long as you can see what is the differences between them. Okay, explanation for in figure. Okay, figure the last slide. Figure 11:14 shows a pair of tapered roller bearing mounted directly and indirectly with bearing impression location at A naught and B naught shown in the shaft. You can pause this video, you go back to this video, or you have the textbook with you. It's better. You can see concurrently. For the shaft as a beam, the span AE, active span, it is to point A naught and B naught radial load acts perpendicularly to the shaft, and the thrust load act along the shaft axis. The geometric span AG from the direct mounting is greater than from the indirect mounting. Okay, the with indirect mounting, the bearings are closer together compared to direct mounting. However, system stability is the same. Thus, direct and indirect mounting involves space and compactness, need or desired, but the same with the same system stability. So the differences is a bit, okay. You can see near and far, near and far, and you can see, okay. In addition to Azure rating and geometry information, catalog data for tapered roller bearings will include the location of effective force center. Okay, two sample pages from Timken catalog are shown. This is the Timken catalog. Many more. It is an whole page. Whole page. If you see in the textbook, if you have the textbook, if you it is a whole page full. I just take a little bit of it just to make you understand. It will show the distance. Of course, if you tow long distance, you will have the bending problem. If too short, also we have problem, but it is recommended by the tinker company that the distance is recommended for the position of the tapered roller. Okay, so radial load on tapered roller bearing. Radial load on tapered roller bearing we induce thrust reaction. The load zone includes half a roller and subtend to angle of approximately 180 degrees. Okay, symbol F induce radial load. The Tinker product equation Fi, okay, equals to 0.47 Fr over K. K is the factor of K factor is geometric specific, and ratio of radial load rating to thrust load rating. The K factor can be first approximate with 1.5 for the radial bearing and 0.75 for steep uh, angle bearing. Okay, so K is 1.5 for the radial bearing and 0.75 for steep angle. Okay, for preliminary selection. Okay. So Fi in induced thrust load. Okay, Fi induced thrust load. Fr radial load. K is the 1.5 for radial bearing and K equals to 0.5 for steep bearing. Okay, steep angle bearing. So this is the equation given by Timken company. Okay, shaft supported by a pair of direct mounted and temporal bearing is shown in figure 11.16. The force vector is shown applied to shaft FRA, FRB are radial load. Okay, you can read all the statement and following the form of equation 11.12 where Fe equal to, this is from equation 11.12, you are familiar with, you also have done an example calculation using this equation in the previous video. Timken recommended using x 0. Equals to 0.4 and V equals to 1 for all cases. Remember, V equals to 1 for roller bearing, V equals to 1.2 for cylindrical roller bearing. But Timken recommended using the standard V equals to 1 and X equal to 0.4. Using the K factor for specific bearing, it is like this. Okay, 0.4 for FR, K, VA. You see here, you see FE, V, you see this equation, V equal to FE equal to X, V, F, R plus Y, F, A. Okay, so using the Timken suggestion, it will become V. You remember Timken suggests V equals to 1, okay, and K factor for specific bearing Y, okay, so replace K equals to Y, okay, so Fe equals to 0.4 F radial load plus K F A axial load, thrust load. Axial is thrust load. So 0.4 is the from the Timken suggestion 0.4 replacing XV. Okay, XV. So we just use the Timken, what Timken suggests. It is a historical company, very existed for a long time ago. We just use them. Okay, they are better understanding on bearing than we are. Uh, so this is the figure 1116. Direct mounted taper roller bearing shows the radial in the thrust and external thrust load. Okay, you can see the difference. You can see, and you can must remember what is the difference between indirect and indirect mounting. You can refer from this video, refer from the textbook, or refer from the Google itself. You can see. And as a load, FA is the net as a load carried by bearing due to competition, combination of induced as a load from other bearing external as a load. However, only one bearing will carry the net as a load. Okay. Okay. As a load, we're talking about as a load. You remember when you are mounting, when you mount two bearings, when you mount two bearings, here and here, both are bearing. Okay. Which bearing carry the as a load? Here, left or right? You do not know. This slide show tell about which bearing that carries the significant load. Okay, left or right. This is what the meaning for all this statement in this slide. Okay, um, you can read. You can read them. Method to give equivalent result. Firstly, determine which measured bearing increased by external thrust load and label is bearing A. First, when you mount the bearing, see with your eye. Okay, which bearing being squeezed by external thrust load. You can see with your eye that one of the two bearing is uh, being forced together, being squeezed together. You find it hard to squeeze one and easy to insert another one. Okay, hard to insert is the squeeze one. You label as A, and another one is easy to insert. Okay, you label as B. Okay, this like that. Okay, uh, external force cause the shaft to push the left against the cone of the bearing, squeezing and against the roll and the cup. On the other hand, it tends to pull the part of cup of the right bearing. Okay, just to read them. Basically, what I tell you, if you read all this statement here, it represent what I tell you. I try to explain within the most easy way. I repeat again. Imagine when you are putting a hole, a shaft in one place. Okay, you find it difficult to insert first one, and you find it easy to insert second one. That first one is squeezed. Second one is not that squeezed. So the first one you label as A, the second one you label as B. And you can read all this statement. You try to understand what I'm meaning by that. Okay. This is example level 7. Example about determining which bearing carries the external thrust load. In each case, the compressed bearing is labeled as bearing A. External thrust applied to a rotating shaft. External thrust applied to rotating cylinder. You can see here. Okay. Determine which bearing carries the load. Okay. Second, determine which bearing actually carry the net as a load. Okay. Meaning there are two bearing, A and B. But what bearing carries the most as a load? Okay. Generally, we expected the bearing A will carry the as a load since the external thrust Fe carries toward A along with induced thrust Fib from bearing B. However, if the induced thrust A from bearing A happens to be larger, the combination of external thrust from the B, then the bearing B will carry the thrust load. Okay, so we use the equation A for bearing carrying thrust load. Timken recommends leaving other bearing is original radial load rather than reducing it to negative thrust load. Okay, what does it mean by in the last slide, I tell you, when you are inserting the shaft, there are two places that you want to insert. Uh, if you find it difficult to insert one place, this is being squeezed, and then this is, you can name it as A, and then another one you find it easy to insert because of more force given to the A. This second shaft is easy to insert, and then you can put it as a B, and of course you will logically at A will carry most of the load. Okay, most of the load. However, sometime, okay, sometime thrust from A, from bearing A happen to be larger than the combination of the thrust. If given the thrust here so large that it effect to the B, and then B will carry the load. Okay, sometimes it happen like that, meaning that for some application, you can imagine what application, uh, the thrust force given at A through B is affected at B. Okay, so the B will carry the load. Instead, at actual, initially, it is difficult to insert at A. Okay, but when during the operation, during the machine run, the machine rotate and the shaft rotate and everything, the thrust is more through A up until B. That is B carrying the load. But logically, A will carry the most load. But sometimes it happen like that. Okay. So try to understand what I'm giving an example like this. Okay. So this is the equivalent load, and this is the equivalent load. Uh, okay. You can find this is for the Tinker company. You remember, it is originally from the equation F equals to Fe equals to X K X B F R plus Y F R, something like that is from this equation. But Timken has suggested to replace this with 0.4 FR plus K F A. Okay, Timken has suggested we use what Timken has suggested. Okay, uh, from this is how you get the equation 1119 A and 1120 A. Okay, and once equivalent radial loads are determined, they should use to find the catalog load using any equation 11.3, 11.9, 11.10. As before, Timken use a well big model. X not equal to 0, theta equal to 4.48, and B equals to 3 over 2. So that's all. Okay, that's all for the video. We see you in the next video. Okay, we are going to do example 11.8. So wish you the best. Thank you very much.